Now let's look at the same form of the first order recurrence relation. When is it actually becoming a geometric progression? When your R value is actually common ratio is the same as your B, and the C value is actually equals to 0 here. That is when you have geometric progression in the form of recurrence relation or difference equation. While you know that AP will always give you a straight line graph, GP, it will actually give you an exponential curve with common ratio R. Okay, your common ratio you always times with the common ratio. Now, what are the features of the exponential curve here? You have a different scenario for different value of your common ratio here. First, when R value is more than 1, so that means your term value will increase as the N value increases. So how would the graph look like? Exponential curve. So as the N increase, your term increases as well. Okay. Now what about the other scenario? What if R value common ratio is in between 0 and 1? That means your term value will decrease as the N value increases. So how would the graph look like? It means as the N increases, your term value decreases. So this is exponential decay, right? Now, what if the common ratio is actually less than 0? That means you have a special case here. The term value will actually alternate in sign. That means they will change from positive to negative and negative to positive accordingly. So your graph will look something like this for the third scenario. This is your N, this is your Tn, and you will have something like this. Alternate in sign. Okay. And this is how your graph will look like. It actually alternate in sign. Okay. Now let's look at how to solve example 9. So they want you to plot a graph of the first 5 terms of the sequence defined by the recurrence relation with this. So they want you to plot the first 5 terms. That means your N being from 1, 2, 3, 4, 5. There are 5 of them. You're supposed to plot the graph here. Okay? We are going to look at the CAS calculator later, but we highlight the keyword first from the question. The next one is, does the recurrence relation here actually having a long-term increasing, decreasing, or steady state solution? So you have to decide based on the diagram drawn which of these is actually applicable to the graph. Okay, right, so I'm going to write out the information from the question here. Right, so with this, use a purple. So from here, the information given being Tn plus 1 equals to 2.5 times Tn. Okay, with T1 equals to 2. Right, so if I want to use the calculator, I have to put it in the terms of the calculator language. So if you have been using the CAS calculator, you know the calculator term is always in the form of UN. What is the previous term? 2.5 times UN minus 1. And with the initial term for your CAS calculator is the same as here, which is 2. Now go to your CAS calculator, press on button. Okay, until you have this view here, you go to list and spreadsheet, right? So you know your N is actually start with 1, 2, 3, 4, 5. So I press 1, enter, 2, enter, because there's only 5 of them, so I can just enter manually like this. 1, 2, 3, 4, 5, and then I go to the top of the cell there. Then I go to B column here. I press menu 3 data 1 generate sequence. So I just key in the one that I've stated here, 2.5 times open bracket no times U bracket n minus 1 close bracket, right? So what's your initial term here? Initial term they say is 2. So n max because they say 5 terms, right? So you delete whatever 255 here, you type in as 5. Then you either click here OK or you just enter here will do. So there you go, you have the output. So I'm going to put this into the diagram here. So let's see, I go back to the purple. Right. So I'm going to plot when n equals to 1, Tn equals to 2. So somewhere here. Okay. So this is just a rough estimate, right? So when n equals to 2, it's actually 5. Okay. This one I put a bit more accurate here. So 2 is somewhere here. Okay. Then when n equals to 3, you have 12.25. So 12.25 is somewhere here. When n equals to 4, 31.25. This is 31.25 is somewhere here. When n equals to 5, you have 78.125. 78.125. Somewhere here. Right? So this is how your graph look like. So this is the answer for E part. Then we'll look at B. So does the recurrence having a long-term increasing, decreasing, or steady state? Steady state, that means it goes stagnant, right? So in this case, you know that it's actually going upward, increasing. So the recurrence relations here has a long-term increasing solution.